Hi, this is Tim with Intercoms Online. One of the most common questions people ask us when they are in the market for a two-way radio or wireless intercom is what kind of range can I get using them? Unfortunately, asking this question is along the lines of asking how far is up. There are lots of variables involved and no easy definitive answer. A brief lesson on radio signal transmission is required to understand the whole range issue. Unlike AM radio signals, two-way radios communicate line of sight. This doesn't mean that you have to see between the 2 points, but the signal travels in straight lines and does not bounce off the atmosphere like AM radio signals, which can travel for hundreds of miles. Two-way radio signals can bounce off surfaces and penetrate objects, but they move in straight lines. Since the Earth is curved, these straight lines eventually go off into the atmosphere in about 4 or 5 miles. Only by raising the antenna height on one or both sides can you extend range further than that. To find the line of sight distance to the horizon for any given antenna height, we can use the formula horizon in kilometers equals 3.569 times the square root of the antenna height in meters. So if the antenna height of a radio is at 6 feet or 1.82880 meters tall, then the horizon is 4.83 kilometers or 2.99 miles away, which is point B in the illustration. Of course, this calculation assumes the receiving antenna is laying directly on the ground, so raising its height would extend line of sight. Point C in the illustration shows another radio with an antenna of 6 foot, so theoretically you should be able to communicate almost 6 miles. So realistically, for two people carrying a handheld two-way radio, the maximum communication distance on flat ground with no obstructions is about 4 to 6 miles. But there are lots of other factors at play too, as we will touch on. So you may be wondering why you see radios that have range claims of 25 miles or higher. Technically, they could communicate that far. Point D shows a radio tower sitting on top of a mountain. If your radio is connected to an antenna on top of this tower, now your antenna height overcomes a whole lot of the Earth's curvature and you can communicate much farther. Other factors that play into how far a radio will broadcast are obstacles encountered along the way, the power output of the radio, and the transmitting frequency. Obstacles reduce transmission range by partially blocking the radio signal. The more power in watts a radio has, the more likely it will overcome these obstacles, so increasing the power of a radio also helps get the maximum range. But the more watts a radio uses to transmit, the lower the battery life on battery-powered devices. Transmitting frequency also plays a huge role in how far a radio can effectively communicate. To understand why, we need a brief lesson on wavelength. There are two formats for two-way radios, ultra-high frequency or UHF and very high frequency or VHF. Sometimes instead of the term frequency, you'll hear the term wavelength, which is a measurement of the distance between the peaks of two consecutive cycles of a radio wave. Lower frequencies produce a longer wavelength, or the width of each cycle gets bigger on lower frequencies. What is significant about wavelength for two-way radios is that it affects transmission range under certain conditions. A longer wavelength, which corresponds to a lower frequency, as a general rule lets a radio signal travel a greater distance. VHF frequencies typically travel over longer distances using less power than UHF radios. So for many outdoor applications, VHF may be the best choice, but not always. UHF signals are better able to travel through tight, small spaces easier, so that makes them better in areas with heavy trees or for use in buildings. To explain this, let's use a microwave oven to illustrate what's going on. The glass front door of a microwave has a metal mesh with very small holes. Microwaves, being an extremely high frequency, have wavelengths that are only several inches long. These tiny mesh holes keep the microwaves trapped in the oven, but it allows you to see inside because the light waves have a microscopic wavelength that can pass through the mesh. Assuming no penetration of radio signals through walls, if you're using a radio in a building, the walls and doorways can act like the metal mesh in a microwave. For a UHF radio signal, the wavelength is about 1.5 feet wide, and a similar VHF radio signal is around 5 feet wide. When the UHF radio transmits its signal, the 1.5 feet wide wave will pass through a door since the door is wider than the wavelength. This is much like light waves passing through the mesh in the microwave. The VHF signal will be totally reflected since it is wider than the opening to the door. just like the microwave radio waves in our microwave oven example. So just imagine walking through a concrete and steel building carrying a 5-foot wide pole. You'll encounter the same challenges a VHF signal encounters. Now imagine walking through the building with a pole that's only 1.5 feet wide like a UHF wave. There are lots fewer doorways you couldn't get through. Of course, nothing about radio waves is quite as simple as I described here. Wireless signals will penetrate through drywall, masonry, human bodies, furniture, wall paneling, and other solid objects. All these objects will reduce the signal strength, though. The more dense the object, the more it reduces the signal. VHF will penetrate these obstacles better than UHF, so if you're planning to use VHF radios inside a building, they may work perfectly fine for you as they do for lots of our customers. It all depends on the square footage you need to cover and what's in the way. VHF or UHF, there's not always a clear choice which one's better. To summarize, if you're planning on using your two-way radios mainly inside buildings, then UHF is likely the better solution for you. But in lots of cases, VHF could work fine if it doesn't have to transmit far. If you're mainly using two-way radios for communication outside, then VHF would be a good choice unless the area you're trying to cover is heavily wooded or there are lots of buildings in the way of the radio signal. Either radio technology can work for you if you really don't have a long range to cover. If you want more information about what we discussed here, we have a detailed article located at intercomsonline.com in the article directory. Or you can contact our product experts at intercomsonline.com and let us help you make the choice.